Hello, welcome to the part 2 of linear programming. So ladies and gentlemen, I hope what we discussed in part 1 of the introductory part, you have gotten some of the clues, the concept and everything about linear programming and what linear programming is all about. Now in this actual example, I want to read out first of all the actual example, okay? Now once we read out the example, I'm going to just, answer the question that we have at the end of this statement, okay? So now the thing is saying that, or rather the statement that you have been given is saying that a trade school makes desks and chairs using two workshops 1 and 2. Now to make a single desk, 1 hour is required in workshop 1 and 2 hours in workshop 2. For a chair, 1 hour is required, okay, in each workshop, okay. So we're saying that one chair, you are given the amount of time to manufacture or to make a chair, which is just 1 hour, is required in which in each of the workshop, meaning workshop 1 and workshop 2. Workshop 1 is available only for 6 hours. The profit from each desk sold is 550, and then the profit from each chair sold is 475. So the question is saying formulate a mathematical model for the given information, okay? So this is some condition statement that we have been given in the question, but we are being asked to formulate the mathematical model, meaning interpret this condition or rather this statement and convert it into a mathematical way of understanding it, okay? So ladies and gentlemen, now the easiest way of answering this question is probably we might decide to come up with a table that will now simplify whatsoever that is in the statement question, or rather in the statement which is a conditional statement, okay? That would be so easy for us to come up with the equation. I think and I feel that would also help each one of us to just get the glimpse of formulating mathematical equation from this question that we have, a statement. Now, so let's now dive into the answering this question, okay? Okay, so I've drawn the table, so I hope each one of you can see that table. Now, what I want to say is that the easiest way in understanding linear programming is probably you can come up with a table that summarizes whatever that was spoken in the statement of the question. Now, ladies and gentlemen, I think there's a small error there. We didn't talk about the 4 hours available for workshop 1, meaning the manufacturing of the desk as well as the chair. We are only given that 4 hours is available, as workshop 2 had more hours than workshop 1. So meaning a lot of things were manufactured in workshop 2. Now without wasting much time, you can see the table now down below, okay? You can see the table. I hope that can be seen. Okay. Okay, so I'm trying to check out if you can see the table. But anyway. Okay, so now you can see that we have how many columns? 1, 2, 3, 4, 5, and then the item we are dealing with a desk, chair, and then also we have the second column which is a number per desk and chair, and then also the third column which is a profit per desk and chair, and then also the fourth column which is a workshop 1, and then we are given that 4 hours is available to be in workshop 1, and then the last column, the fifth column, which is a workshop 2, 6 hours is available for that workshop. Now you can see that in the number the number of desks, okay, so the number of desks are being represented by a mathematical variable later, which is just x, and then also y is being represented by this one. Y is being represented by, chairs are being represented by y, and then also the profit when we sell each of the single material, or rather a product that we are making, meaning the desk we make 550 when we sell, and then the y we are making 475. You can see that we are making more desks than we are making the chairs. Probably this is one of the the maximum profit we can go as far as we are doing business, or maybe we need more ways in which we can try to maximize, make more profit but also spend less expense. Okay, that's one of the function of linear programming. It's not just to be doing business anyhow. Okay, so you discover that the hours, workshop 1, 4 hours there. 4 hours there, meaning that only one desk was manufactured. Okay, and then also within workshop 1, also one chair was manufactured, and then in workshop 2, 2 desks were manufactured, and then also one chair was manufactured. Okay, so now the best way in order to answer the question is formulate a mathematical model for the given information. Okay, so it's just a matter of saying that okay, okay, so this is just going to be so you look at the time that is available for the workshop 1 and the workshop 2. Okay, so we have 2 workshops, so we're saying that x plus y, okay, should be less than or equal to 4 hours. So meaning the number of the desk and the chairs, when you put them together in terms of the hours available, okay, in terms of the hours available, we should ensure that we don't exceed, we don't exceed 4 hours. Okay, now from there we in fact the one that I talked about, this one, and then the other one is that only 1 hour was used for the desk, and then 1 hour was also used for the chair. Okay, so meaning that if you wanna understand what is going on, this is just 1 hour times the number of desks that we are manufactured, plus 1 hour times the number of chairs that were made should be equal to 4 hours. Okay, so this one just equals to x plus y equals to 4, and then this symbol now should be changed to a mathematical model. Okay, so this is x plus y should always be less than or equal to this. Okay, so this is number 1. And then when you look at number 2, we are going to say, when you come to the 6 hours that was available for workshop 2, you'll discover that we used 2 hours for making extra desks, and then also we used 1 hour for making Y chairs. Okay, so to find the total amount of time that we use is the 2 hours multiplied by the number of chairs that we produced. Okay, so this is going to be 2 times x plus 1 times y. then should be equal to 6 hours. So remember, workshop 2 was a variable for 6 hours. So this is going to be 2x plus y equals to 6. 2x plus y. This the symbol equal sign should be changed to a linear, an equation or an inequality symbol, like less than or equal to, greater than or equal to, or just less than or just greater than. So this should always be less than or equal to 6. Okay. So this is number 2. So for the part of time, that is how you're just supposed to answer that. Okay. And then there is what you call standard equation. Those are, it's a must, you must include them. Okay, so the first one is x should be greater than or equal to 0, which is just x equals to 0. Then y is greater than or equal to 0. Okay. So these are what we call the standard equations that should always be there. So this is number 3. So we'll understand more under this one when we do other example. Okay, so just know that for the sake of argument, just know that there's also standard equations or inequations, which is x is always greater than or equal to 0. The reason why we are having that, we just want to avoid the negative part of the thing. Okay, so because we cannot have x negative of the desk or x or y negative of the chairs. Okay. Then about the profit, we are going to say that the profit is that when we sell each desk, and then or whatever the number of desks we produce, which we are not sure, but when we sell in total, we're making a profit of 550 for the desk. Okay, so the desk, so times x. So if you want to know how much profit we made for the entire desk that we have, then just to multiply to count how many desks you have in your workshop, and then multiply by the profit from one desk. Then also plus the profit we're making, as stated out in this in the statement. It was that for the chair we are making 475 kwacha per chair. Okay, so we want to say how much did we make for the all chairs. Okay, and this should be equal to the profit. Okay, the summation of the profits. Okay, so you do that. This is going to be 5 is the x plus okay, so that's it, ladies and gentlemen. What we have just done is just a kind of not so detailed, but I believe and hope that I'm going to upload from the start of the topic up to the end, of which this thing will come and revise it. Okay, so all I can say is that make sure that you go through, you understand what linear programming is, specifically on the part that we have tackled. Make sure you go through this until it will start making sense. Okay, so it will not make sense at the moment because I've not done the introductory part, but of course if you have the notes, that would be much okay, and indeed very amazing and awesome. Okay, so that's it. Welcome to the end of this course. So I believe and hope that you have gotten 1 or 2, 3 concept about this mathematical model or linear programming in general. So I'll see you in the next video, which will be now about the entire video from the introductory part all the way up to the the summary, of which we shall revise again what I've just talked about this mathematical model. So thanks for watching so much. Please don't forget to subscribe, like, and share. Also go to our Facebook page, which is Learn with Mike Wada. Also our YouTube channel, which is Radical Academy. Please subscribe, share, like our channel, so that whenever we post any kind of a content, you'll be the first person to be notified that we have posted a video. And also on our Facebook page, which is Learn with Mike Wada. There on our Facebook page, you find also plenty of videos in various subjects. And then just make sure that you like the page. You also follow the page, so that even when we post from either of the platform, okay, we'll be able to be notified that we have uploaded a new content, a new video, and you'll be able to see what you can do and just make a timetable when you can have that video be able to access it when you have the bundles. Okay, so it's bye bye. This is Radical Academy, and my name is Mike Wada. I'll see you in the next video.